Hello, so I'm going to go on with the marking of the homework. Sorry that I'm not there today, so we're going to mark homework and then you're going to receive a new chapter and then you must study for your test. Alright, so at question E, they say we have ammonium chloride and they say that's a salt and that's your clue. Sorry, so the name there is ammonium chloride. And then because it is a solid, because it is a positive ion connected to a negative ion, that is your clue that it will undergo dissociation. Okay, so we said previously that because it is, that because it is a metal, it undergoes dissociation. Here, this is a tricky one because it is a salt or a solid. It undergoes dissociation. So you'll see ammonium chloride will react with water, not with water, in the presence of water, and you will receive ammonium ions and chloride ions. Alright, then question F, you have there H2CO3, that is a liquid. The name there is carbonic acid, something that you must know. Now, the clue here is because it is an acid. Okay, because you have an H there, because it is a liquid, it undergoes ionization. Okay, so that is where it reacts with water. Sorry, that must be liquid and liquid. It reacts with water, and here the hydrogen will react with water and you'll get the hydronium ion aqueous and a carbonate ion aqueous. Okay, that is like the previous example that we did with an acid. Here you can see we had sulfuric acid, so it ionized, it reacts with water, and we said because there is two hydrogens. Okay, so two hydrogens interacts with two waters. We said that is a diprotic acid. You remember that? The same thing here. It's an acid. It ionizes. So there's two hydrogens. So we're going to say it will react with two waters and will form two hydronium ions. Again, a diprotic acid. A di meaning two, protic meaning protons, acid. Right, then the next one there is question G. We have potassium chloride, solid. It is a solid, it is a salt, it's a metal bonded to a non-metal, so it means it will dissociate. Okay, the name there is potassium chloride. Okay, so we have potassium chloride, and in the presence of water, it will dissociate, it will split up into the two ions. So you have potassium ion aqueous. Aqueous means surrounded by water. And you have your chloride ion aqueous. And then the last one there is NaNO3. The name there is sodium nitrate. Okay, so you see a metal bonded to a non-metal. They also tell you it's a salt. So that is your clue, the metal, the salt part, or the solid part, that it is, or it will undergo dissociation. So you have your sodium nitrate, solid. Dissociation means in the presence of water, it will split up into the two ions that you get, sodium ion aqueous and your nitrate ion aqueous. All right. Then you had homework. You had to do 7A and B and 8A and B and C. Yes, if I'm correct. I'm going to do all the questions at 7 and all the questions at 8. So mark as we go on. Sorry. Ay, dochie. No. Sorry about this. Change template. Okay. Right. So at question 7A, all of them, they ask you calculate how many grams of solid. So we must calculate the mass. They say at A we have a volume of 200 cubic centimeters. You say, no, I don't like cubic centimeters. That is the same as milliliters. We want it in liters or decimeters cubed. So you must divide by 1,000. So that is 0.2. Right, they say the concentration is 0.1 and they say we're busy with sodium chloride. The reason why they give us that is so that we can calculate the molar mass. The molar mass here will be 23 plus 35.5, so you get 58.5. Right, so if you calculate the concentration, we're going to use the second formula. Well, we want to calculate mass. The concentration is 0.1. The molar mass there is 58.5 and then the volume is 0.2. So the mass is at the top of the fraction. We are happy with it there. But so we must get rid of this bottom part. How do we get rid of it? We multiply with it on both sides. So we're going to multiply on both sides. So you get mass is 0.1 times 58.5 times 0.2. That is what you must fill in on your calculator. So if we do that, sorry, then you get 1.17 grams. Okay, question B. They say there we have a volume of 100 cubic centimeters. Again, you say no. We must divide by 1,000, so that is 0.1. So the question is again to calculate the mass. The concentration here is 0.5 and they say we're busy with potassium hydroxide. The reason why they give us that is so that we can calculate the molar mass. So that is 39 plus 16 plus 1 and that gives you 56 if I'm not mistaken. So concentration is mass over molar mass times volume. So that is 0.5. We want the mass. The molar mass is 56 and the volume is 0.1. Right, again, the mass is at the top. We're happy with that. We must get rid of that. How do we do that? We take it to the other side and we multiply with it. Ne? Right, so we have mass is equal to 2.8 grams. Okay, question 3 is a bit more difficult. They say there we must calculate the mass. The volume is 500 cubic centimeters. The concentration is 0.25 moles per decimeters cubed. And then they give us copper sulfate dot 5 waters. Now that 5 waters means that it is surrounded by water, or we can say it is a hydrated salt. This here is a salt. So if this can be represented by an X and this be represented by a circle, then what it will look like is it will be an X with 5 circles around it. So it's just a salt crystal surrounded by 5 water molecules. This is like when you have salt and you leave it open and it becomes cloggy. Cloggy, is that a word? Then that is what you get. You get a hydrated salt crystal. Okay, now that dot here is not the same dot as in mathematics. That dot does not mean multiply. That dot means plus. I know that is confusing. Right, so if we must calculate the molar mass of that, copper is 63.5 plus sulfur is 32 plus 4 times 16, so 4 oxygens, plus, the dot is a plus, 5 water molecules, so it's 5 times 2 times 1 plus 16. Right, and if you calculate that, I just want to double check because I have made a few errors today. Then you get 249.5. Alright, so if we must calculate the concentration, then the concentration is 0.25. The mass we want to get, the molar mass is 249.5. And the volume, sorry, I forgot to say that, cubic centimeters, we don't like that. We must convert, that is 0.5 cubic decimeters. Right, so you get the mass then to be 31.19 grams. Then question D, the last question there, says the volume is 1 decimeters cubed. We're happy with that. Yes. The concentration is 0.01. And then they say, sorry, we must again calculate the mass. And they say there we have oxalic acid solution. So that is COOH with a 2 and then again 2 water molecules. So it's again the same as the top. That dot means a plus. So if we calculate the molar mass, remember this 2 here means 2 times everything on the inside. So it's 2 times 12 plus 16 plus 16 plus 1 plus, 2 times 1 plus 16. So that is a big calculation that we must do. So it's 2 times plus 1 plus 2 times. And you get 126 there. Okay, so mass will be, not mass, concentration is mass over molar mass times volume. The concentration is 0.01. We want to get the mass. The molar mass is 126 and the volume is 1. And if you calculate the mass there, you get 1.26 grams. All right, then we go to the last one there. We go to question 8. So for question 8, they ask us that we must calculate the concentration for each one. Now what makes this difficult is I didn't give you the formulas. Well, you must first go calculate the formula. So they say there the mass is 20 grams. Then they say we're busy with barium hydroxide. Okay, so here you must know your valencies very well. So we have barium plus hydroxide is OH, ma'am. How must I know that? You must study it. You must also know that the valency is -1 and barium's valency is 2 plus. Ma'am, how do I know that? You look on your data sheet on the periodic table and you see barium is in group 2, so it means it's +2. If this is +2 and this is -1, it means we need 2 hydroxides for that. So it will become barium and we need 2 hydroxides. Right, now if you have that, you can calculate the molar mass. Now I don't have my periodic table in front of me. So we need to get the molar mass for barium. Oxygen is there, and there's 2 of them, is 2 times 16 plus 1. I'm so sorry about that. I must get my periodic table somewhere. Okay, let's quickly get it. Okay, barium molar mass. There we go. 137. Okay, so it is 137. Thank you, Google. So if we calculate that, then we get it to be 173. Oh, no, not 173. I'm sorry. I did the wrong calculation. 171. Okay. Right. So to get the concentration will be mass over molar mass times volume. I forgot to write down the volume. Let's say the volume is 400 cubic centimeters. We say no, we don't like that. We must divide by 1,004. So the mass is 20, the molar mass is 171, and the volume is 0.4. And if you calculate that, you get... I'm sorry. I'm slowing down a bit. So that gives you 0.29 moles per decimeters cubed. Right, question B. They tell us the mass is 50 grams. Then they say we're busy with lead nitrate. Again, we must use our valencies to determine the formula, because the formula will determine the molar mass. So we have lead there and we have nitrate. Ma'am, how am I supposed to know that? You study it. Lead's valency is 2 plus, something you must study, and nitrate is minus. You see this is -1, this is +2, so we need 2 of the nitrates to cancel that out, so that we get lead nitrate, like that. Why do we need that? To calculate the molar mass. Lead's mass is... Bim. Did they give it here at the bottom? No. Let's calculate, let's see. Lead 207. Okay, so it's 207 plus, remember that 2 means 2 times everything on the inside, so 2 times 14 plus 3 times 16. And if we calculate that, is 331. Yeah. So I want to double check. Alright, and then they also tell us the volume there is 200 cubic centimeters. Again, we don't like that, so we must convert to 0.2. Okay, so concentration is mass over molar mass times volume. So the mass is 50, the molar mass is 331, and 331, and the volume is 0.2. And if you calculate that, you get 0.75 moles per decimeters cubed. Question C. They tell us there the mass that we have is 10 grams. Then they say we're busy with silver nitrate. They say the volume is 200 cubic centimeters. And again, cubic centimeters we don't like it. That's 0.2. No, I am wrong. They said 350. So that's 0.35. Okay. Right. Again, silver nitrate, we must go calculate the formula. Silver plus nitrate. Silver's valency is +1. Ma'am, how should I know that? You study it. Nitrate is -1. How do I know that? You study it. You see they cancel out perfectly, so you get silver nitrate like that. The reason why they give us that is so that we can calculate the molar mass. Silver's mass is, let's see. I think it's 127, but I might be wrong. 108. Okay. 108 plus 14 plus 3 times 16. And you get the mass to be, I hope you guys are calculating with me. You get 170 grams per mole. Alright, so concentration is mass over molar mass times volume. So it is 10 over 170 times 0.35. And you get the answer to be, and I'm just double checking myself, 0.17 moles per decimeters cubed. Okay, then the last two questions, then we're done. Grade 11, I promise. Question D. They ask us calculate the potassium ions concentration. So we want potassium ions concentration. They say the mass is 13.8 grams, but they say that is the mass of potassium carbonate, so the whole thing. And they say the volume is 250 milliliters. We don't like milliliters, we want liters, so divide by 1,000, that's 0.25. The reason why they give us that is to calculate the molar mass. So the molar mass of that will be 138. Okay, so we have a problem now because all the information they give us here is regarding potassium carbonate, and then they just want the potassium's valency. So how are we going to go from the one to the other? You'll see that we can take potassium carbonate, and because it is a salt and because it has a metal, it will dissociate in the presence of water to form 2 potassium ions and a carbonate ion. So the ratio of molecules to ions is 1 to 2. 1 molecule gives me 2 ions. Yes, it also gives me 1 carbonate ion, but I'm worried about the ratio between these two because that was the question. Okay, so I know if I get the concentration of this one, I can just multiply it by 2 to get that one's concentration. So I'm going to do 2 calculations. First, the concentration of potassium carbonate. It will be mass over molar mass times volume. So that's 13.8 over 138 times 0.25. And you get that concentration to be, sorry, and I just want to double check. As you know, I also make mistakes. 0.4. 0.4. Then we say, right, so the ratio of potassium carbonate to the potassium ion is 1 to 2. We got that from here. So we can say the concentration of the potassium ion is 2 times 0.4, and that gives me 0.8 moles per decimeters cubed. And then the last one, question E, they ask for the concentration of the hydroxide ion. They say the mass is 3.7, and they say we're busy with calcium hydroxide. Okay, and then they say the volume is 500 milliliters. No. That is 0.5 liters. Again, it's the same type of question. All the information that they give us is regarding the whole thing, but they ask just the concentration of the hydroxide. So we are going to again write the dissociation reaction. Ma'am, how do we know that it dissociates? Because it is a metal, and because it is a salt, this thing is a salt. Okay, right, so you can see it. One calcium hydroxide molecule gives you 1 calcium ion and 2 hydroxide ions. So the ratio that we're interested in is the 1 to 2. Okay, so first I'm going to calculate the concentration of this whole thing, because they give me information regarding the whole thing. So that's 3.7 over, we haven't calculated the molar mass yet. Sorry about that. So that gives you 74. And the volume is 0.5. So we have the concentration to be, 0.1. But we know we don't want the concentration of the whole thing, just the hydroxide ion. So the concentration of the hydroxide ion will be 2 times 0.1, and that gives me 0.2 moles per decimeters cubed. Alright, so grade 11th. That is all. You'll get a new chapter. Please take it, and we will start with that in the next class.